Morning once again, beta.
Good morning, ma'am.
Morning, ma'am. Good morning, ma'am.
Thank you, beta. Go to pay this one, right? Conduct,
Yeah,
conduction tester using LED. We had used it with the wires. Now we are going to use with LED, right? Start, beta.
Conduct,
Conduction tester using LED.
conduction tester using LED. Sometimes the current flowing through the circuits may be too weak and the what's it?
Filament. Filament.
filament filament of the bulb may not get sufficiently heated to make it glow. Then
Hmm.
instead of a torch bulb, an LED can be used in the circuit. LED glows even when a weak circuit flows in the circuit. Weak
Weak
current
current, but
flows in the circuit.
okay, it's okay. What have you understood from this, beta? Are you aware of LEDs?
Yes.
So what is the function of LED? First of all, that whenever there is a weak current, we can see the bulb glowing. Whereas in other bulbs, if there is a weak current, the bulb does not glow because the filament does not get heated up or the element does not get heated up, isn't it? See, why do we get light? Why do we get light, beta? Excuse me. Because when the element gets heated up, it starts burning and we get the light, isn't it? And that's the reason that the bulb, right? This is the bulb, isn't it, beta? So when this filament gets red hot, then only we get the light. You understand? If the current is very weak and the filament or the element does not get heated up or does not get red hot, we will not get light. So at that very moment, which sort of device will work? LED. Because LED does not require strong current to work. It can even work with weak current. You understand? So whenever weak current is flowing in the circuit, if LED is present, it can start functioning. It can be functional. Okay, beta? Girls, did you understand or not? Hello? Are you understanding or not? Girls, can you hear me, beta?
yes,
Hello? Yes. Now you can see this is the circuit, this is negative, and this is positive, and this is the LED. Okay? You understand that? If there's a weak light, weak current going on, this LED will start glowing. These are LEDs. Okay? All these are LEDs. See, red, yellow, green, orange, all of them are LEDs. This is how they work. They're functional. Fine? So the only thing that you have to remember is that if there's a weak current, except LED, not a single device will be functional. They will not work. If you take any other device, for example, you take an ordinary bulb, and if there's a weak current flowing in the circuit, it will not work. And if we replace with LED, then yes, it will work. This is the only thing that you have to understand. Yes, girls, you get me? So what is LED? Why it is important? LED is important only when the weak current is flowing through the circuit, and that's it. That means it is consuming less current. LED consumes less current. Am I right?
Yes, ma'am.
Yes? Okay, fine. Yes, start.
Conduction tester with a magnetic
Using a
compass.
using a using a magnetic compass.
Conduction tester using a magnetic compass. If a magnetic compass is kept near a wire and current flows through the wire, the magnetic needle gets deflected. So we can use a magnetic compass instead of a torch bulb or LED in the circuit. The magnetic needle gets deflected even if
A
a
weak,
current
but it is a weak.
if a
Even
weak
if the weak
current
current flows in
flows
this.
in the circuit.
Fine. Now, first we saw LED. That LED works with weak current. Now, next is we can have magnetic needle deflection even in the weak current. So, what we observe? First, LED working with weak current, and we will have a magnetic field with weak current. You understand? And we will do the activity again. What we do? We keep a magnetic compass. You know now what is magnetic compass, beta? Showing north south. Remember? Have you ever seen a magnetic compass, beta? Hello, girls, can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes. Have you ever seen magnetic compass showing north and south direction? It is used in aeroplane. It is used in ships. Any navigation is used. Even in vehicles, you can use it. And when people go for trekking, they also use
Yes.
it, right? So when this magnetic compass, see how does it look? This is how it looks. See, have you observed this magnetic compass, Peter?
Yes.
Yes. Okay. So when this magnetic compass is kept near a wire, that means it's kept near a circuit, and the current is flowing through the wire. What we will see? The needle will start deflecting. The needle will deflect. Deflect means it will move like this. It will move like this. Okay? This needle talking about. So needle will start moving. So that's called deflection. So instead of bulb or instead of LED, we can use the magnetic compass, right? To show that the electricity is moving and it is causing the deflection in the magnetic compass. This deflection is observed even in a weak current which is flowing through the circuit. This is the circuit. Got it? Understood better? So what we learned? Weak current flows LED, weak current shows deflection in the magnetic compass. Any problem? Excuse me. Any problem, beta? Hello? Girls, any problem, beta? Hello? Girls, have you understood? Hello? Girls, can you hear me? Hello,
Yes, ma'am.
can you hear me?
Yes, ma'am.
Now we'll see electrical conductors and insulators. So, should I ask you what are called conductors, beta? What are called conductors? Can anyone give me the example or the definition of conductor? What are conductors?
Ma'am, from where the electricity flows.
Through which? Not from, through. Which word you will use, beta? Instead of from, what you will use? Through. The
Yes.
object through which the current flows. Yes, beta? The object through which the current flows is called as conductor. Yes or no?
Yes.
So, which allows the electricity to pass. This is another way of presentation. The object through which the electricity can pass is called as conductor. For an insulator, the object which does not allow the electricity to pass through is called as insulator. Okay, let's read.
Conduction of electricity. Similar to many solids, some liquids also conduct electricity. Conductor substances which allow electricity to pass through them are called conductors, such as silver, gold, acidic solution, salt solution, etc. Insulator substances which do not allow electric current to pass through them are called insulators, such as plastic, rubber, etc.
Thank you. Now we know solids are conductors, metals, copper, isn't it? Hello, iron, all these are conductors of electricity. We've got silver, gold, all these are metals. Now, along with metals, some liquids also conduct electricity. So first of all, we find out what are conductors. These are the substances which allow electricity to flow through. They are conductors, example, silver, gold. Now let's talk about liquid. Liquid are acidic solution, salt solution, common salt, that is, you put sodium chloride, the salt that we eat, and put it in water. That solution can conduct electricity. Insulators are the substances which stops or which do not allow the electric current to pass through. These are called insulators. Example, that whenever we are ironing, we are not barefoot. Remember that. We are not barefoot. We are using bathroom slippers. Yes or no? Yes or no? While ironing our clothes, what we use? We use bathroom slippers. Because if we are barefoot, we may get current. We may be electrocuted. So the rubber is an insulator, so we are safe from electric current. Then we can use plastic also. So these are the substances which are termed insulators. Is it clear, better? Girls, is it clear?
Yes.
Yes? Oh, yes. Read. Again, the same topic but another slide. Some information you will get from this. Start better reading.
Conductors and insulators. All substances do not allow electric current to pass through them. Based ability, substances are divided into two categories: conductors and insulators. Substances that allow heat or electricity to flow through them readily are called conductors. For example, metals are and some non-metals such as graphite are good conductors of electricity. Substances. Man, your screen is blurred.
Substances that do not allow.
The substances that do not allow the free flow of charges through them are called insulators. For example, dry wood, plastic, rubber, wool, and cotton are insulators.
Thank you. Now, conductors, same thing. Based on the ability, the substances is allowing the electric current to pass through. We are categorizing into two. One is conductor, the other one is insulator. So substances that allow either heat or electricity to pass through. See, in the earlier slide, what we learned? Electricity to pass through. Yes or no, beta? Yes? In the earlier slide, in the earlier slide, please put off your mic, beta. In the earlier slide, what we have learned that electricity is allowed to pass through. In this slide, what are we learning? Heat and electricity. Have you observed the difference? Girls,
What, ma'am?
in the earlier slide, conductor meaning is that the electricity should pass through, isn't it? That is conductor.
Yes.
In this slide, what we learned? Heat and electricity passes through. You understand what I'm trying to say? So from each slide, we are getting something new to the definition. What do you say?
Yes, ma'am.
Yes? Okay. So what have we learned in this slide? That it allows heat and electricity to flow through them readily. They are called as conductors, no obstruction whatsoever. Examples are metals and certain non-metals, that's called as graphite. They are good conductors of electricity. And substances which do not allow the free flow of charges or free flow of electricity. By the way, what is electricity? It is the free flow of electrons. It is the free flow of electrons or the
Electron.
charges. So electrons are also called as charges. So don't be confused. And this makes electricity. They are called as insulators because they do not allow the flow of electricity through them. Example, plastic, rubber. In addition, we got wool and cotton. They are also insulators. Any problem?
No, ma'am.
Any problem with her to understand? Hello.
No, ma'am.
Now we know what are conductors. We are going to again categorize the good conductors and bad conductors. Let's see. See, so many ways we are trying to specify it, trying to understand. So please revise it right here. Understand it right now so that you don't have to revise it again. Got it? Yes, beta?
Good conductor and bad conductor. Substances which allow electric current to pass through them easily are called good conductors of electricity, such as silver, gold, aluminium, etc. Some substances allow electric current to pass through them but in very little amount. Therefore, such substances are called bad conductors of electricity rather than being called as insulator.
So understood
In
what is the
fact,
difference over here? Just a moment, better. What we learned earlier, conductor and insulator, right? This is what we had learned. Just answer me better.
yes,
Yes. Now what we are doing? We are talking about good conductor and bad conductor. So what is good conductor and bad conductor? Good conductors are the conductors which allows electric current to pass through them in lots of amount without any hindrance. That is good conductor. And what is bad conductor? That the substance allow electric current to pass through them, no doubt about it, but in very little amount. So it is passing, the electricity is passing, but in very little amount it is passing. That those substances are called as bad conductors. What are they called as, beta? Bad conductors. Okay?
bad conductor.
So we will not call them insulator, but we will call them bad conductor because see, electricity is passing through them. So it cannot be insulator. Electricity is passing through them, no doubt about it, but little of electricity is passing through them. That's what they are called as bad conductor. Yes, beta.
In fact, most of the substances allow electric current to pass through them under certain conditions. So, instead of using terms conductors and insulators, good conductors and bad conductors are used.
Okay. We generally know that most of the substances they are allowing electric current to pass through. Now, if it's solid, if I melt it, maybe I can pass through electricity through that. Maybe in solid, not able to, but in liquid, yes, I can. So we will not use, that's what they say, they will not use the conductor as, uh, uh, as conductors or insulators, but instead we will use good conductors and bad conductors. Do you understand? Because hypothetically, if you take and if you see that most of the substances are allowing the passage of electricity in one way or the other, too much or too less, but they are allowing. So we will not use the insulator and the conductor, but instead we will use good conductor and bad conductor according to them. Okay, please begin.
Electrical conductors are materials that allow electric current to flow through.
Okay,
Examples:
examples.
salt
Yes.
water, metals such as copper, aluminum, and non-metals like graphite, a form of carbon.
Okay. So the conductors generally allow electric current to pass through. We have salt water, I just told you that you just dissolve salt in water, in potable water, dissolve it, it becomes salt water solution. It is a electric conductor. Then we have metals, for example, copper, aluminum, and we have non-metals also like graphite, which is a type of carbon. So orange colored, can you see this? Orange colored. This is copper. This one is silver. This one is aluminum. These are graphite. Can you see this? And where do you get graphite? In the pencil. See here, this is graphite. Can you see this? The pencil
Yes.
tip is the graphite. Okay? This is the graphite by which you write. It is carbon. Remember that. It is the allotrope of carbon. Okay? Electrical conductivity of solids. Please begin. Yes, beta.
Electri- Electrical conductivity of solids. Some solids are good conductors of electricity. Example: copper, steel, iron, aluminium, etc. Some solids are poor conductors of electricity. Example wood, plastic, rubber, glass, etc.
So we know that solids are good conductors of electricity. Some solids, and we have already seen the example as copper, steel, iron, aluminium, and many others. And some solids are poor conductors of electricity. That means, rather, we can say the bad conductors of electricity. They are wood, plastic, rubber, glass, etc. I think now things are very clear. Good conductor and bad or poor conductors, and we have got the examples as well. Now here's the wood. You see this wood over here? Yes? You see this wood better?
Yes, ma'am.
Yes? Now the bulb will not glow. If I put iron over here, the bulb will glow, suggesting that wood is a bad conductor of electricity. You understand? So you can take pieces of wood, pieces of iron, pieces of silver, gold, whatever, and do this experiment by completing the circuit. If the bulb glows, it is good conductor. If the bulb does not glow, then it is bad conductor. Do you understand? Hello? Do you understand better?
Yes, ma'am.
We're going to talk about electrical insulators or the bad conductors. Please begin.
Electrical insulators. Electrical insulators are materials that do not allow electric current to flow through. Examples plastics, wood, rubber, glass.
Fine. So, what are insulators? Electrical insulators or bad conductors of electricity? They do not allow electric current to flow through, or if at all they are flowing, it's very little. Examples you already know is plastic, wood, rubber, and glass. You can see over here, this is rubber, this is wood, and these are plastics. Okay, so through these articles, the electricity do not flow. So we will do certain activity to see the conduction of electricity through liquid. Okay, please. Yes, start better. Someone please take up reading.
Liquids
Shifa.
which con- liquids which contain salt dissolved in them conduct electricity. The conduction of electricity through a liquid can be tested using two electrodes and a bulb. But the conduction of electricity through the liquids, which are poor conductor, cannot be tested. But conduction of electricity through such liquids can be tested using LED or magnetic compass needle. For this, you need a compass needle, an empty matchbox, two electric cells, some wires, a plastic bottle cap, and the liquid which is to be tested. Keep the compass needle inside the empty tray of matchbox and wrap a couple of rubber bands around it. Connect the wires to the battery and insert two wires in the liquid which is kept in the plastic bottle cap.
Yeah.
You will observe that when the current flows through the wire, there is deflection in the compass needle. This shows that the given liquid conducts electricity. In fact, magnetic compass needle can detect even feeble current. LED can also be used in place of compass needle.
Needle. Right? Here, you can see over here. This is a circuit. Can you see the circuit better? Hello? Can you see the circuit? This is the battery. This is the needle, compass needle. This is the mains, that is switch, right? And the circuit is complete. Can anyone explain? What are we trying to see? Yes, girls. We take a liquid and we'll dissolve salt into it. We know that the salt solution conducts electricity. What we do? We will take one bulb and we take two electrodes. See over here. These are two electrodes, and in between we can put a bulb. We can put a bulb, right? We can put a bulb on. And this is the salt solution. Got it? Girls, can you hear me? Girls? Girls, can you hear me, beta? Hello? Girls? 8th standard? Hello? Hello? Am I audible? Hello? Girls, can you hear me, beta? Girls, can you hear me? Hello, can you hear me? Yes, beta, can you hear me? Hello, can you hear me, beta? Alpesh, sir? Answer me, please. Speak up. Girls, can you hear me? Hello? Can you hear me, beta? Hello? Girls, please speak up. Hello? 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 Girls, can you hear me? Hello? Zeda, can you hear me better? Alvina? Hello? Hello, girls, can you hear me? Now, the liquids which are poor conductor, you cannot test with this mechanism. But we can use LEDs or magnetic compass needle to test the conductivity of the liquids. We need a compass needle, a matchbox, two electric cells, some wires, a plastic bottle cap, and the liquid that you are taking to be tested. We take a matchbox, see this is the matchbox, and we'll put the compass inside the matchbox, and it should not move. So what we'll put? We will put rubber bands on top so that it will not move. Then you have to connect with battery and put two wires which will be behaving like a electrode in the liquid, and that liquid is in the plastic bottle cap. What you will observe that when current starts flowing through the wire, the compass needle starts deflecting. That shows very clearly that the liquid that you are testing conducts electricity. This magnetic compass needle is very useful. Why? Because it can detect, it can find out even a small current which is passing through. And we also know that instead of needle, the compass needle, we can also use LEDs. Understood, beta? Hello? Did you understand? We also know that the salts, which is dissolved in water, they can conduct electricity. So generally, tap water, it has got some certain chemicals, certain salts, certain minerals in it. Acid solutions, basic solutions, they are good conductors of electricity. Distilled water, which is actually pure water, which is used in injections in hospitals, and because it does not have any salt in it, so it is a very poor conductor of electricity. See how you test the conductivity of liquids. Let's see. If you take two aluminum plates and put it in the liquid, and if you see the bulb lighting up, you see this is the bulb lighting up. So a circuit is formed, that means current is flowing through it. which shows that the liquid is conducting the electricity. Okay? Now we'll see what are the chemical changes due to electric current. Whenever any electric current is passing through a solution, we can see certain bubbles in the liquid. What are these bubbles made up of? These are obviously made up of gases because chemical changes have started occurring. That's why you are getting those bubbles of gases. Either you can see that the solution of the of the tested, the one which you are being testing, the color may change. There may be cloudy formation that is called as precipitation, or the solution temperature may change. Either it will go cold or it will become warm. These are also a type of chemical reaction or a part of chemical reaction. In this case, you can see these bubbles coming over here. These are the bubbles, right? That shows that the chemical reaction has taken place. And this is how we see the chemical changes over here. The color of the liquid may change. And in this case, you can see this. It's a lemon juice. It's acidic juice. Lemon juice is citric juice. So the bulb will start glowing, showing that lemon juice is a good conductor of electricity. Any problem, beta? So I think we will call it a day and we will redo certain slides once more, once again when we meet next. Okay, beta? Have a good day. Bye.